Welcome to the Cool Tools Show. I'm Mark Frauenfelder, Editor-in-Chief of Cool Tools, a website of tool recommendations written by our readers. You can find us at cool-tools.org. I'm joined by my co-host, Kevin Kelly, founder of Cool Tools. Hey, Kevin.
Hey, it's great to be here.
In each episode of the Cool Tools Show, Kevin and I talk to a guest about some of his or her favorite uncommon and uncommonly good tools they think others should know about. Our guest this week is Paul Boswell. Paul is co-founder of Turing Tumble. He's been an analytical chemist, a software engineer, a professor at the University of Minnesota, and a healthcare researcher. 4 years ago, he progressed to the next obvious step in his career, becoming a toy maker. And I just have to say that it's been a number of years, but Paul, you had a really successful Kickstarter with your Turing Tumble, which is a kind of mechanical, gravity-powered, like Boolean logic computer kit. Is that kind of right?
That's a good description. Yeah, thanks so much for having me on.
Yeah, definitely, Paul. So yeah, I'm really looking forward to your picks here.
Yeah. We're delighted you could join us, and we're eager to hear what tools you want to share with us. All
right. Well, I'll start with the first one. So I am an analytical chemist by training, and so I've seen a lot of chemistry experiments, and I got to say, when I heard about cool tools and I was going to be on this, I got a little fixated on the cool part, and it reminded me of one of the most memorable birthday parties we had for our kids. So I have 3 kids, and my youngest son was turning 5. His name is Henry, and he really likes chemistry experiments. He doesn't understand what's going on. It's just like watching magic for him. But it doesn't really matter. It's a good experiment. It just is fun. So he wanted a chemistry-themed birthday party. And at one time, I was a professor at the University of Minnesota, and I taught a general chemistry course there. And it was one of those big lecture halls with like 500 students. And they even had a dedicated person on staff to set up class demonstrations. And he was really good. He knew all the best experiments. And I had just as much fun, probably more fun than my students running the demos in the class. But anyway, there was one experiment that I'll never forget. It was just that amazing. So I decided to do that experiment for my son's birthday party. It's this cool chemistry experiment that anyone can understand, and it's a blast to watch. And that is the first cool tool, is this chemistry experiment, because you can whip it out for a birthday party or whatever, and it's really fun to watch. So magnesium. All right, so magnesium metal is a very light, sturdy metal, and it really, really likes oxygen. It wants to bind to it very badly. And, you can bind, or you can light it on fire, and it just rips oxygen out of the air and binds to it, right? And it burns super hot and super bright at 3,000 degrees. And at the end, you're just left with this hunk of white material that's magnesium oxide. So people, normally buy magnesium to start campfires. Like you can get it on Amazon. Mm-hmm. So here's what to do. So you take 2 slabs of dry ice, and you can get the dry ice from like your local grocery store. They usually get them with their frozen food deliveries. You drill a little hole in the bottom slab of dry ice. So you have 2 slabs, and you have one on the bottom, one on the top. And you drill this hole, and maybe it's like 2 inches diameter. And you put magnesium shavings in the hole. You don't fill it to the top, and I'll get to that again later. You leave a little empty space on the top, and then you make sure that the second slab of dry ice fits over the top slab and the hole before you continue. Then you take the top slab off, you light the magnesium on fire, and maybe you need to use a propane torch to get it hot enough, and then you quickly cover it again. Okay, so dry ice is made of frozen carbon dioxide. And carbon dioxide, if you don't know, is made of it's a molecule with 1 carbon atom and 2 oxygen atoms. It's a stable molecule, and it doesn't react with hardly anything. Now, the magnesium wants to burn, and it wants to pull oxygen off of something, but there's no oxygen there when it's inside this carbon dioxide block, right? So how does the magnesium burn? And the way it does it is it binds with the oxygen that's in the carbon dioxide. So it actually rips the oxygen out of the carbon dioxide, and what's left is carbon. So the magnesium burns inside the dry ice, until it all burns out. And then you open it up and you see this nugget of burnt magnesium, and you crack open the nugget and it's just black inside because all that's left is carbon from the carbon dioxide. Okay, so it's this really cool experiment. It looks really neat, glows brightly while it's burning.
So cool.
So we did this experiment after the birthday cake, and we had some of his neighborhood friends over. They're all, 5, 6 years old. We did some chemistry experiments, ate some cake, and then it was time for this one. And so my wife and I had them stand way back so they were, completely safe. And I lit the magnesium on fire, covered it up with the top slab of dry ice, and everything was going great. I turned out the lights, and the dry ice was glowing and spewing out fog from between the slabs. And it grew more intense and more intense and more intense. And now the chemistry demonstrator that had done this before, he knew not to fill the hole all the way to the top with magnesium, but I didn't know. So I figured I'd just fill the hole all the way to the top to make it last longer. And so the magnesium was burning, burning, burning. It was making this noise, going like shh, getting louder and louder. And, the kids are watching it, and it's kind of this eerie glow. And eventually the little flecks of magnesium started shooting out the sides. And, magnesium you can't put out. Like it's...
yeah, right.
When it's burning, you can't put it out. So there's these little flecks of magnesium that are escaping the dry ice and like burning little holes in the table and the wooden floor. And the kids were pretty nervous before that. But then when they saw a look of concern in our eyes, watching our table get little pock marks in it, then they started getting a little anxious. And after a minute or so, the magnesium burnt out and the room was filled with this haze of water vapor fog. And I tried to show the kids how, all that was left inside was the carbon. They didn't care. They just had like this shocked look on their faces. And I asked the kids, "Are you ready for the next experiment?" And one of the kids says, I think I want to go home now." And I said, "Are you sure?" And he said, "Yeah." And then another one said, "Me too." And so these poor scarred children left to go back home. And my wife and I had to explain to their parents why they left the birthday party scared. But it was kind of fun because then after that, I was really proud of my 5-year-old because he came up and he said, "I want to do the next experiment. Can we do it now?" So anyway, if you decide to do the experiment, just remember 2 things. 1, do it outside. And 2, don't completely fill the hole with magnesium.
Great advice.
Yes.
So that's the first cool tool.
Yeah, magnesium is unstoppable once it gets burning. And I remember during the early days of Burning Man, people would make bonfires out of anything. And someone threw a magnesium bicycle into it, and it caught on fire. It was so hot because you have to have a very high temperature. But it was like crazy. I mean, it was just it was like a furnace.
Wow! I bet it lit up the whole area.
Yeah. So it is. Once it gets going, it's almost like thermite. You kind of like you can't stop it.
Yeah.
That's great. So what's another tool? Maybe a little bit less pyrotechnic. Something that won't scare the 5-year-olds.
Yeah. Okay. So if for whatever reason you happen to have little burned holes in your wood flooring or table or whatever, there's actually you can actually repair a lot of problems in your wood flooring without having to refinish or replace anything. So we were trying to figure out how to replace or how to fix these little black marks in our wooden floor. And so we stumbled across this guy who fixes wood floors for a living. And we asked him if he could repair it. And he was like, "Oh, yeah, sure." So he came by and he had this tackle box just full of different types of paint. And the first thing he did is he got this wood repair epoxy. It's like the Elmer's wood repair system that I put a link to. And he filled the hole with the epoxy and let it get hard. And then the next thing he did is he painted the grain of wood very carefully with acrylic paint. It turns out the guy was actually an art major. who just got really good at painting wood grain and went into doing this full time. So he filled the holes, he painted the grain that was missing, and when he was done, we couldn't even see where the holes had been. He was that good. It was really something.
Wow.
That's cool.
So the first half of this you can buy, which is the Elmer's wood repair system. The painting is going to be up to you.
That's right. Yeah, it's just acrylic paints he used, I'm pretty sure. But if you're good with painting, and I don't actually think you even need to be all that good. He was excellent, but I think if you can just come close to whatever the grain was underneath, I think you can just paint on with acrylic, and it covers it up really well.
Cool. Okay, so and Elmer's wood repair it's an epoxy 2-part epoxy. Is that right?
That's right. Yep.
Yeah, like a putty.
Yep.
That's really cool. I didn't know about that. That's really cool. Yeah.
Yeah.
I mean, some people sometimes would take sawdust and glue, and you could kind of patch things up with sawdust and glue. But does this actually have wood in it, or is it just straight epoxy?
I don't think it does. I think it's kind of like you described, kind of a putty. There's 2 parts you mix together. It's not like straight up epoxy because it's not a liquidy sort of thing. So it's mixed with something to make it more of like a putty, and then you can kind of shape it in there and get it the way you want it before it hardens.
Okay, great. So what's your third tool that you want to share?
Okay, so the third tool is it's not particularly unusual. So it's a Ultimaker 3 3D printer. So, I'm an educational toy maker now, and the type of toys that I make are very mechanical in nature. And, the main point of them is to make important abstract concepts into something that you can see and feel. I think our brains are really wired to understand things that we can touch and see and interact with. And if you think about it, we don't have to do any math in our heads to decide how hard to throw a ball to get it into a basket. We just do it, right? And it's the same with science. If you can make abstract concepts tangible, it becomes so much easier to digest and understand and apply it to other things. So a big part of prototyping for me is making physical objects and mechanisms. And, I don't know how people did it before 3D printers. I've tried a lot of 3D printers. The first 3D printer I tried was a really long time ago. It was a Kickstarter I got when 3D printing was just taking off. They're the main tool I use now. So of the 3D printers I've tried, and I've tried quite a few, the Ultimaker 3 is by far the most reliable machine I've used. I can send files to print and they work 9 times out of 10. And one thing about this one that makes it especially useful is that you can print with 2 materials at once. So the really good thing about that is that you can use, for one of the materials, you can use just your regular material, your regular plastic that you're using to actually form the structure of the material. But then the second material can be something that you can dissolve in water and just wash away. So normally you'd have supports on it or something to hold that up, because you can't print on overhangs or places where there's nothing under it to support it, right? But if you can use a water-soluble support, then after it's done printing, you can just dissolve it in water and you have any object that you want to print.
Mm-hmm. That's really, and so the 2 filaments, are they going through the same print nozzle, or are there 2 nozzles?
Yeah, so that's the thing. There's several ways people do it, but the Ultimaker 3 has 2 nozzles, and it switches back and forth between them at every layer.
Wow. So that slows it down then.
It does. So it's a fairly slow printer. So, compared to other printers, it's probably half as fast.
Right.
But
also, you said that it's very reliable because it prints 9 out of 10 times.
Yeah.
That.
Yeah, I know you wouldn't think that would be great for certain contexts, but for 3D printers, that's astonishingly good.
Is this what you use to do your Turing Tumble parts?
Yeah. most of the parts I created on that, some parts were like the board was too big for it. So for that, I actually sent out to have that made someplace else. But everything else I made on that.
Well, that says something about it. And did you say how much it cost?
Yeah, so it's a fairly expensive 3D printer. So it's, a lot of them are around $1,000 for a quality printer. This one's $3,000. So it's significantly more expensive than typical 3D printers. For me, it's totally worth it, though, because I don't have to worry about things failing nearly as frequently.
And what about like filament getting stuck, which seemed to be the problem I always encounter with my Prusa? Is this, when it does fail, what kinds of failures does it have?
That's a good question. I think the biggest hassle is trying to figure out, I guess this isn't a printer issue. It's more an issue with the water soluble filament. So polyvinyl alcohol is the typical one it's the one that comes with the printer, but it's kind of an odd material, and it doesn't print particularly well. It soaks up water really fast, and then it doesn't print very well. But finding a good material is kind of half the battle. There's other companies that make them. Yeah, so that material kind of plugs up. So if you use polyvinyl alcohol, it kind of plugs up in there, and you have to sort of clean that out every time. Yeah.
Okay. Well, that sounds like a good one for serious 3D printers.
Right. A lot of the high-end printers have seemed to move to the resin printing. Are you considering this, or does Ultimaker 3 is it comparable to a resin printer?
That's a great question. I actually have a resin printer too. It's a Form 3 printer, and it lets you do things that you can't do with an Ultimaker or a printer like that. But it's messy. It is so messy, even with all of the tools that come with it to try and make it cleaner. So resin printers work by, you have this kind of a tray, and there's sort of a goopy resin that you put in it. There's light that shines from the bottom and hardens parts of it. And then it moves up a little bit, and then it shines again on the bottom, and parts where the light hit harden again, and then it moves up again. So the problem is the goopy stuff. So when you're done, you have your object hanging from the build plate, and it's covered in this goopy resin, right? So the first thing you do is you have to clean it off with isopropyl alcohol. But now you have a whole bunch of dirty isopropyl alcohol with this resin in it, and the resin just gets all over all kinds of stuff. And the resin doesn't last forever, so it sits in the tray, and if it's there for a couple months, it hardens by itself. So I've used resin printers. I have one right now, but it's actually a lot less work and possibly even less expensive just to order it from a website. I use i.materialize. It's a Belgian-based company, and you can just upload a model there, and they'll do a resin print for you and mail it to you within, a week or two. So I don't get it as quickly as I would like, but it's so much less messy. And the quality is just as good or better than what I can get from my resin printer.
And would you, using that method of sending out for resin, would you actually first print a regular one on your Ultimaker to make sure you had it right, and then have it sent out?
Yeah. So resin printers are very good at getting precise dimensions. You can get things just like they would be, or just like the 3D model that you made, right? It prints and it comes out with very accurate dimensions. Whereas on the FDM printer or an Ultimaker like printer where it's doing it layer by layer with hot plastic, they're close, but they're not quite as good. And you have, rough edges, and it's just not quite as good as a resin printer. So they're definitely better quality, but it's messy.
Yeah. Okay.
You have another tool here that's only twice as much as the printer.
Yeah, sorry about that. These are kind of expensive,
No,
these last two here.
It's interesting to learn about these things.
Yeah, so these two machines, I put them here because they are the main instruments I use. So the Ultimaker 3, I use for most things. It's great for getting things close. The Pocket NC is the fourth tool. So Pocket NC is kind of a miniature CNC mill. So CNC mills, well, CNC stands for computer numerical control. And basically what it means is that you have a mill, which is just like a router blade spinning really fast on the end of a tool. And that router blade is, one way to think about it would be a router blade on a robotic arm that goes around and cuts material out of some block. So whereas 3D printing, you're adding material to build something, with a CNC mill, you're actually subtracting material, you're cutting it away from a block of that material. So most CNC mills are 3-axis. That means you have like a blade that's spinning and it can move forward, backward, left or right, or up and down. And that's great if you have like a flat surface and you're cutting or engraving something from it. But a 5-axis CNC mill can not only move forward, backwards, side to side, up or down, it can also rotate along 2 axes. So you can cut out pretty much anything you want out of a block of material, as long as the blade can get to it to cut out that spot.
Wow.
So usually these machines are, very expensive. They run for well over $100,000. But this little Pocket NC, I think it also began with a Kickstarter. It's only $6,000, and it's shockingly precise. It only does small objects, so maybe a 6-inch by 6-inch by 6-inch, probably even a little smaller than that, maybe 5 by 5 by 5. But it's pretty incredible. So the really good thing about this is that you can make objects that have a smooth surface, that are very smooth. You can make objects that have really small features in them. And you can make them out of virtually any material you want, because you just put a block of the material down and it cuts away from that material. So if you're making something like a gear, like a little gear, you can't do it with 3D printing. You just can't. It doesn't have the resolution to be able to do that. But you can do it with a CNC mill. And when it's done, it's nice and smooth, and it's made out of the material you want. So it has a space. The downside to CNC milling is, number one, the cost. So even though this machine is far, far less than a typical 5-axis CNC mill, it's still pretty expensive. And then the other thing is the time it takes. So it takes a while to learn how to use it, but it's not at all like 3D printing, where you just give it a 3D file and hit slice, and it basically comes up with exactly how it's going to print it for you. With a CNC mill, you have to be very specific about how you want it to cut it, how you want to cut it out. Maybe you do a certain pass to cut out this portion first, and then you have to tell it to cut out this portion second. And you have to be very specific. Do you want the side of the blade cutting it out, or do you want the top of the blade cutting it out? Just it takes a while to actually come up with the plan for how it's going to cut it out. And then when it's running, you often have to switch tools. So maybe you start with a big tool to cut away a lot of material. Then you go down to a smaller tool to cut away the smaller spaces, and then maybe a really tiny tool to cut out the little features in it. So you can't just say run and have it go. You could spend 2 or 3 hours kind of letting it run, and then switching the tool, letting it run some more, switching the tool, letting it run some more. So it's kind of a labor-intensive tool, but it's for me, it's just indispensable. I've spent so many hours on that thing.
Is there software that helps you, like, with figuring out tool paths and changing the cutting tools and all that, or do you have to like manually figure out all of that?
Yeah. So the software I've used is Fusion 360. It's an Autodesk product, and it does a lot of work for you. So if you say, I want to cut out this section and I want to do it a certain way, it'll figure out the toolpath to do it for you. But you still have to be surprisingly hands-on in the way that you want it cut out.
And you mentioned before the benefits of sending out your piece to a resin printer and getting it back. Would this also be a place where maybe people would do a CNC for you on material, and you would just send it out to them, who they might be expert in figuring out toolpaths and stuff like that?
Yeah, absolutely. That's a great question. So there are a lot of CNC milling services out there. The bad part is that they're pretty expensive. So having a part resin printed isn't bad. Maybe a typical part would be $20 to $30. But to have a part CNC milled is well over $100 each. And so if you want to have, if you want to make a lot of iterations on a part, like, I was trying to get these gear tooth profiles just right so that when there was a load on them, they didn't, click, click, click every time a tooth crossed over another tooth. And I probably did 30 or 40 different iterations to try and get it just right. And if I'd have had that made someplace else, it would have taken a really long time because there would have been at least a 2-week turnaround for each version. And then it would have been expensive as well. So this machine paid itself back easily for me, for the kind of things I do.
Right. Exactly. Well, that's really super.
And did you have to get an enclosure for it so that the little pieces of cut material didn't fly all over the room?
Yeah.
Catch fire and burn your floor?
Yeah, I haven't cut out any magnesium with it yet. Yeah, I did. With the Pocket NC, there's an enclosure that you can get with it, and I would highly recommend that. I think without it, it would be loud, and you'd just have a pile of, I mostly cut out plastic. There would just be a pile of plastic all over the place. So I definitely recommend the enclosure. Yeah, that's right.
Cool. Paul, if readers wanted to hear more about what you're up to and what you're doing, what's the best place for them to check you out? And also tell us about your recent project, the one that you're working on right now.
Oh yeah, Kevin, you'll love this.
Okay, so that mechanical computer is Turing Tumble. That we have a website for that at turingtumble.com. So the new project. Okay, so I really like electronics, but it's always been such a struggle for me to understand a circuit. It's just so mentally taxing to try and figure out how the voltage is changing and the current is moving at each point in a circuit over time. It's just too much to handle all at once. And there are just a lot of circuits that I just have always struggled with. And I felt like if I could have some sort of a physical representation of that circuit, it would be so much easier. If I could feel the voltage or see the current moving through, or just kind of mess with it, just put your fingers in the circuit and mess with it, that I could understand it so much better. So for the last 3 years, I've been working on this mechanical version of electronics. And I think it's actually the first physical version of electronics ever built. So what it is instead of wires carrying electrons through them, you have chains that run between sprockets. The chains move just like current through a circuit, and every electronic component, you have a counterpart, a mechanical counterpart. So you have a mechanical resistor, you have mechanical capacitors, mechanical transistors, mechanical battery. Every electronic component, there's this mechanical counterpart, and then you connect them together with chains to make circuits. So, you can make all kinds of circuits with it. And I've actually learned an awful lot about electronics doing this. But the cool part about it is that I think it provides a new way to learn about electronics that's so much more tangible and understandable than it is trying to understand what's happening inside these invisible circuits. So it's called Spintronics, and we're actually launching a Kickstarter on the 20th of this month, we're really excited about it.
And the idea is that it's kind of a modular system where you keep adding parts as you make your circuit more complicated, and you can kind of rearrange things like a Lego-ish way. I'm just curious. Besides, kind of like resistors and diodes, do you also have like transistors?
Yeah. Yep. But I'll tell you, the most challenging part to make was the easiest part in electronics. The part I hadn't even really thought of as being a part in electronics, and that's junctions. So where you have one wire splitting into two wires, that is the hardest thing to do. And the reason is because, so we're modeling it with a chain, right? Now, probably the easiest way of thinking about electronics, though it's not the easiest to build, is water flowing through a pipe, right? So when water comes to a junction, like a T, like where it splits in two, some of the water goes down one junction and some of the water goes down the other pipe, right? So, some of the water comes in one pipe, all the water comes in one pipe. Some of the water goes out one pipe, some of the water goes out the other pipe, right? But if you have a chain, you can't split it down one pipe or down one way and have the chain split the other way. And, even if you could split the chain in half, it would still be going too fast because the speed of the chain going down each of the two pipes should add up to the speed of the chain coming in. It's hard to explain. Right. But to behave like electronics, it has to split in a certain way.
And so what was your solution?
So if you're familiar with differentials, they're used in cars to make the power go to one wheel or to the other wheel or kind of a combination of the two, so that when you turn, one wheel is turning a little more than the other wheel, and that's okay. The differential sort of supplies power to whichever wheel needs it at the time. And so what I had to do is make a differential that could not split the chain, but create two separate loops that when the current goes in one part of the differential, the current two paths for current leave it, and they have the right current going through each of them. It's a little bit difficult to describe, but that was the most challenging part to make. It was so difficult. I spent months on that part. I made so many iterations until it finally worked well. And it's so basic.
Wow.
Like, you learn about series and parallel. That's like the first thing you learn about in electronics. And series circuits don't require any junctions, but a parallel circuit does, right? Mm-hmm. That's where you have the voltage going in, it splits to two lights and then goes back to the battery, right? But there's that junction there. So making that parallel circuit, once I got that to work, I finally knew I had it. That was the big moment that I knew this was going to work. Just that simple little parallel circuit.
That's
so I guess
cool.
Like a diode could be like a ratchet.
Yeah, exactly. I made a diode, but it turns out I didn't actually need to include a diode in the kit, because if you use a transistor and a junction in a certain way, you can do the same thing. But yeah, exactly. Okay. A diode is just like a one-way. It turns only in one direction. Mm-hmm.
Yeah, a little ratchet. Wow, that's cool. Well, I'm so excited to see that. We'll certainly have a link. That's really cool. I have the same kind of mental handicap with understanding circuits as well. I know there was some people doing simulations at one point. Some guy was working on a pretty good simulation of circuits where you could, a drag and drop kind of a visual thing, but that's not at all like a physical manifestation, which would be really
They help
cool.
a lot. Yeah. I've spent so much time with those. It helps a lot.
Do you have one to recommend?
A lot.
Do you have a circuit simulator that you would recommend is maybe better than the others?
Yeah, so one I use frequently is Every Circuit. So it's everycircuit.com, I think.
Every Circuit, you say?
Yeah, every circuit. Yep.
Okay.
So it's great for just getting a kind of an idea of how circuits work. You can watch a circuit and it shows you the flow of current through a circuit. It'll show you the voltage at different points in the circuit without even having to like specify, I want to see the voltage there or I want to see the current there. It's very nicely done visually. So I would definitely recommend that. Yep.
Every circuit. Okay, that's really great. Well, that's a great bonus. And besides your Kickstarter, is there anywhere else that people can head to see what you're interested in these days?
That's so. Our business kind of started out of the blue. So like 4 years ago, like Mark was saying, I did this Kickstarter for Turing Tumble, and I had no idea that it would do as well as it did. We were shooting to raise $40,000 for injection molds, and there is no way we would have, paid for that on our own and taken the risk. But we did this Kickstarter, and we ended up raising $400,000. And so I ended up taking a leave from my job. They wouldn't allow me to take a leave, so I just had to quit to work on production. And then we figured out kind of how to do advertising and marketing, and we got it working. So for the last 4 years, I've been kind of working on that. And then mostly I've been working on this new Spintronics product. So I don't really have like a separate sort of thing about me, but Turing Tumble and Spintronics are the two things I've spent a good chunk of my life on the last, for a long time now.
Yeah, looks great.
Well, sounds good, Paul. We'll have a link to the Kickstarter so that people can participate because it's such a cool project.
Thanks.
And the Turing Tumble is now just available from your online store, it sounds like.
That's right. Yep.
Cool.
Sounds great. Well, Paul, thank you so much for chatting with us. This was fun.
Yeah, thank you so much.
Hey, everybody. It's Mark from the Cool Tools podcast. I want to thank you for being a listener to Cool Tools. And I also would like to let you know about our Patreon page. If you would like to support the Cool Tools show, as well as our video channel, the website, and all the newsletters that we do, you can go to patreon.com/cooltools, that's just one word, Cool Tools, and pledge any amount you want. You could even pledge $1 a month. Every little bit helps. We have editors, we pay for transcribing costs, we pay our reviewers. Every bit of money that you contribute goes towards supporting the show. I'd like to give a shout out to our supporters of the Cool Tools podcast. This week, I'd like to thank the following Patreon supporters: Bill Schuler, Bob Kay, Brian Pelly, Carl D. Patterson, Chad Cosby, Chris Wieland, Chris Weirstook, Craig Tooker, Dan O'Brien, Dean Putney, Danelle Cunningham, Evan Barker, Graham Medlin, Hans Riesbeck, Helen Hegedus, Jerry Kearns, Jim Lesko, Jim Spofford, John Pollock, John Burdenbaugh, Keith O., Ken Altman, Les Howard, Lauren Bast, Mock Nerd, Malton Make, Mark Goebel, Matt Gromes, Michael Douglas, Michael Jones, and Michael Pecorini. Thanks to all of you for supporting the Cool Tools show. We really appreciate it.